Today I'm fabricating a new hydraulic cylinder rod for an excavator. As you can see, the old rod has some deep scratches. These scratches have damaged the cylinder seals, which has resulted in excessive oil leaking and could have possibly allowed contaminants to enter the system. The rod is irreparable, so I'm fabricating a new one. Before I begin machining the new rod, I need to remove the R from the old one. There's absolutely nothing wrong with the old R, so I don't need to fabricate a new one. I'll be using the old one on the new rod. I know in most of my videos it looks like my jobs are always going smoothly and I never run into complications. But believe me, 90% of the jobs always have a little obstacle that slows me down. So for this video, I'm going to bring you along for the full experience. I was attempting to machine out the welding joint between the R and the rod. Usually when these rods are manufactured, the end is machined down to fit firmly into a recess hole that is drilled into the R. But for some reason I couldn't find the bottom of this welding joint. I inspected with a light, hoping to find a crack. There was nothing, so I continued to machine away material, hoping to eventually find a crack. I've machined off a lot of rod eyes before, but this is the first time removing so much material. And even with this much material removed, I couldn't find any joint. I heated it up with a torch, then hit it with a hammer, hoping to find some sign of a joint or crack. But that didn't go as planned. The portion I machined down just snapped. Fortunately, it snapped with a portion of the machined down area still on the R, so I can use that to align with the rod. Now that that's out the way, I can begin the machining on the new rod. The deep scratches on the old rod was caused from impact with rock. You see, this rod is from an excavator's bucket cylinder working in a rock quarry. So it's inevitable that it's going to take impact from rock, which is why I'm using the material induction hardened chrome shaft for this rod. It has a much harder surface area than normal chrome shaft, so I'm hoping that, along with another plan you'll see further on in the video, will prevent rock damage from occurring again. Because what good would this repair be without finding a solution to the cause of the damage? Anyways, you'll soon see the plan I have. Let's get back to the job now. All that's left on this side of the cylinder rod is the threads for the piston. I believe this should be the last cut in the threads. Let's test the piston. That fits 100%. This side of the rod is now complete. Let's flip it around and attend to the other side. This end of the rod is where I need to weld on the R I removed from the old rod. If you can recall, I mentioned the R broke off of the old rod with a portion of machined down still on it. So I've drilled a recess hole on the new rod that suits the portion I machined down on the R. This is going to help me align the R square with the rod for welding. Next, I chamfered the rod for welding. I wanted the machined portion on the R to fit tightly in the rod hole. So I had to heat up the rod to expand the hole so I could insert the R. Once the hole was big enough, I used my center to push in the R and a couple taps with a hammer. And it was now time for welding. Now before you attack me in the comments, I am aware I shouldn't be welding in the lathe. So if it makes you feel better, let's just say I'm demonstrating on how not to weld on a rod R. So here it goes. Don't be like me, don't weld in the lathe. Anyways, I would just like to mention it's important to check your welds after every pass for any imperfections. By this I mean cracks, porosity, lack of penetration, lack of fusion, and undercuts. Cylinder rods work extremely hard, so any imperfections in the welding will result in failure. I'm satisfied with the welds I got, but I need to machine them down to keep the cylinder rod looking as original as possible. Or maybe that's just an excuse to hide my welds. Either way, I'm doing it anyway. And that's all the machining on the cylinder rod complete. It's now time to get the rod out the lathe and onto the workbench. Righto, I'm at the workbench. It's time to reseal and assemble the hydraulic cylinder. Gland fitted with brand new seals. Piston with brand new seals. A closer look at the spanner I had to make to loosen this piston from the old rod. That was another obstacle I had to overcome before I could even begin this repair. I didn't record that because at first I wasn't going to make a video on this repair. But then I hit 100,000 followers on Facebook and I felt motivated again. Making these videos take a lot of my personal time, which I don't have much of. So I would just like to say I appreciate everyone for the support. Before I get too emotional, let's get back to the job now. I mentioned I had another plan to help prevent damage to the new cylinder rod. And this right here is the plan. I've headed out to the quarry to where the excavator is working to fit the bucket cylinder. Now as you can see, the hydraulic cylinder sits right by the bucket. So there's obviously going to be collision with rock and stone chip. So I made this bracket that fits on the hydraulic cylinder barrel and holds a conveyor belt. The conveyor belt will hopefully shield the rod from rock and stone. And that's all for this video. Check you in the next one.